Welcome learners. Now we shall see some of the problems in levels of inventories. From the following information, calculate the maximum stock level, minimum stock level, reordering level, average stock level and danger level. Normal consumption is 300 units per day. Maximum consumption is 420 units per day. Minimum consumption 240 units per day. Reorder quantity is 3600 units. Reorder period is 10 to 15 days. Normal reorder period is 12 days. Time required for emergency purchase is 4 days. So we have to calculate reorder level, minimum stock level, maximum stock level, average stock level and danger level. Reorder level. Maximum consumption into maximum reorder period. Maximum consumption is 420 units per day into maximum reorder period is 15 days. It comes to 6300 units. Minimum stock level. Reorder level minus normal consumption into normal reorder period. 6300 minus 300 into 12 will get 2700 units. Normal consumption is 300 units. Normal reorder period is 12 days given on the problem. Reorder level we have calculated in the above calculation, above step. 6300 minus 3600 will get 2700 units. Maximum stock level. Reorder level plus reordering quantity minus the minimum consumption into minimum reorder period. 6300 plus 3600 minus 240 into 10 will get 7500 units. Average stock level, it is half of the minimum stock level plus the maximum stock level, it comes to 5100 units. Danger level, minimum consumption per day into time required for emergency purchases, that is 240 into 4, 960 units. The next problem, two components A and B are used as follows. Normal usage 50 units per week each. Reordering quantity A is 300 units, B is 300 units. Maximum usage 75 units per week each. Minimum usage 25 units per week each. Reordering period A is 4 to 6 weeks, B is 2 to 4 weeks. Calculate for each component reordering level, minimum level, maximum level and average stock level. Reorder level is equal to maximum reorder period into maximum usage. Therefore, for A, it is 6 weeks into 75 units comes to 450 units. B, 4 weeks into 75 units, it comes to 300 units. This reorder level takes care of the maximum usage during the lead time so that the stock just reaches zero level even if the maximum consumption takes place. Minimum level. Reorder level minus the normal usage into normal reorder period. For A, 450 units minus 50 units into 5 weeks will get 200 units. 300 units minus 50 units into 3 weeks, that comes to 150 units for B. Maximum level. Reorder level plus reorder quantity minus minimum usage into minimum reorder period. For A, 450 plus 300 minus 25 units into 4 weeks, that comes to 650 units. For B, 300 plus 500 minus 25 into 2, that comes to 750 units. Average stock level is half of the minimum stock level plus maximum stock level. For A, half of 200 plus 650, it comes to 425 units. For B, half of 150 plus 750 that comes to 450 units. Average stock level can also be calculated with this formula. Minimum stock level plus half of reordering quantity. For A, 200 plus half of 300, it comes to 350. For B, 150 plus half of 500, that comes to 400 units. Now coming to the next problem. ABC company makes a certain equipment where a part costs 1 rupee per unit. Annual requirement is 2,50,000 in numbers. Lead time is 6 weeks. Demand is 4,810 with a standard deviation of 400 per week. The company wishes to maintain a service level of 95% where capital K is equal to 1.64. Normal lead time is 6 weeks and maximum lead time that occurred in the past was 10 weeks and cumulative probability of its occurrence, that is 7, 8, 9 and 10 weeks is 0.25. The ordering cost is rupees 60 and the inventory carrying cost is rupees 30%. Inventory carrying cost is 30%. Based on this information, calculate EOQ and safety stock for the fixed order quantity Q system and fixed period review P system. So EOQ is equal to square root of 2AU divided by CL, that is 2 into 2,50,000 into 60 divided by 1 into 30%. So we have to find out the square root. It comes to 10,000 units. So EOQ, otherwise the ordering quantity is 10,000 units. The order point, lead consumption plus safety stock to cover the demand and lead time fluctuations. So lead consumption is given in the problem as 4,810 units. Into 6 weeks, it comes to 28,860 units. Standard deviation during the lead time is 400 into square root of 6, that comes to 980 units. For service level of 95%, K is 1.64. So safety stock for demand fluctuations is 980 units, that is the lead time, into the service level K 1.64, that comes to 1,607 units. So that is the safety stock for the demand fluctuations. Safety stock for the lead time fluctuations, average demand during the maximum and delay, that is 4 into 4,810 into probability of occurrence of this delay is 25.25. It comes to 4,810. So total safety stock is, for demand fluctuations it is 1,607, for lead time fluctuations it is 4,810. Totally it comes to 6,417 units. Fixed period review system, EOQ divided by demand. So 10,000 units is ordering quantity into 52 weeks divided by 2,50,000, it comes to 2.08. That is 2 weeks. At the total cost for 3 weeks will be more. Consumption during the lead time plus the review period. So 4,810 into 6 plus 2 weeks, it comes to 38,480 units. Safety stock should cover the fluctuation and demand during the lead time as also the review period, that is 6 plus 2, 8 weeks plus the lead time fluctuations. So for demand fluctuations it is 400 into square root of 6 plus 2 into 1.64, that is your K. That gives to 1,856. So total safety stock is 4,810 plus 1,856, which is equal to 6,666. So 38,480 is the consumption during the lead period, plus 6,666 is the demand fluctuations, so it comes to 45,146. We shall pass on to the inventory reorder and replenishment system, that is the refreshing the system, P system and Q system. The inventory systems are developed to cope up with the situations where the demand or the lead time or both will fluctuate. The basic approach to all stock control methods is to establish a reorder level which, when reached, would indicate the signal for the replenishment action. Thus, the replenishment of the inventory means determining the quantity to be ordered and the time of ordering. The two types of replenishment are fixed quantity system Q system and fixed period system P system. Now, first we will see the Q system, that is a fixed order quantity system. In this system, the order quantity is fixed and ordering time varies according to the fluctuations in demand. The characteristics of this system are: reordering quantity is fixed and normally it equals the economic ordering quantity. Depending upon the demand, the time interval of the ordering varies. Replenishment system is initiated when stock level falls to reorder level. Safety stock is maintained to account for increase in demand during the lead time. The system may be explained as follows. See, we will have the time on your x-axis, stock level on your y-axis. We have the safety stock which is parallel to the time. So we have a minimum level of stock that is maintained for safety stock and we have a maximum level. Now we have the Q1 and Q2 reorder points here, and this is the lead consumption. So when we have this stock level, that is a Q, that is from the safety level to the maximum level. So this is the lead time consumption, right from the safety level to the Q1 and Q2 order points, that is called as ROL. The advantages of this system is, it is simpler to operate. Stock control will be accurate as the replenishment action is initiated soon after the stock reaches the reorder level. This is suitable for the low value items. The appropriate system, this is considered to be the appropriate system for variety of inventory maintained within the organization. In this inventory system, there will be a load on the reordering system if many items reach the reorder level at the same time. So this happens to be the major disadvantage. And again, the records of stock levels and usage rate data are to be maintained. This is also difficult in practice. We shall see how this Q system can be implemented. It is implemented through the two-bin system. The two-bin system operates on ROL system and it physically segregates the stock of the entire items into two bins. The second bin contains a quantity equal to ROL, that is M plus LC. It refers to the satisfaction of demand during the replenishment period. The first bin contains a quantity Q minus LC to satisfy the demand between the receipt of the materials and the placing of the next order, where LC refers to the lead time consumption. To begin with, the stock from the first bin is consumed first. The emptying of the first bin indicates that the stock has reached ROL and the replenishment action is initiated. The quantity in the second bin is thus consumed during the replenishment period. This system reduces the work involved in the record keeping. Next comes the fixed periodic review system. It is also called a fixed period ordering system or a P system, and this system has a fixed ordering interval, but the size of the order quantity may vary with the changes in demand. In this system, the inventory position is verified at a prefixed interval, whether it may be weekly, monthly or quarterly. Then depending upon the situation, the replenishment action is taken. The main characteristics of the system is the order level is fixed, the order interval is fixed for individual items or it may be for the group items. And the stock will be reviewed at periodical intervals, and two, the quantity will bring the inventory to the maximum level is ordered. That is, the stock will be reviewed at the periodical intervals and the quantity which will bring the inventory to the maximum level is ordered. That is from the level when it is to be ordered, then after it is received, it will reach the maximum level. This system is suitable for the high value items which require the stock control on the stock levels. So we will have the lead time here, we have the stock level, and we have the review points here, and we have the ordering quantity. Ordering quantity will be this difference. So the lead time will be from this P1 to this line. Then once again P2 to this line. So that is the lead time. Ordering quantity will be right from this P1 till the maximum level. That is the line it is given. Stock is reviewed at periodic intervals and the quantity which will bring the inventory to the maximum level is ordered. So from P1 to the maximum level, it has to be ordered. Again, in case of stock goes below this, then the P2 point will be lesser than this level, and that from P2 to the maximum it has to be ordered. Suppose its review point is at the height and more than this level, then P3 to the maximum is the ordering point. Now we will compare the fixed order quantity Q system and fixed period order system P system. In Q system, there is a constant monitoring of stock levels and the order is placed the moment the reorder level is crossed. In P system, if there is any big transaction, especially in the closing days of the review period, then the demand may not be fulfilled. But in practice, such a situation is very rare. Q system is suitable for the low unit cost but high volume items. P system is ideally suited for the joint replenishment orders. Joint replenishment facilitates the advance and proper planning by the vendor and reduces its production cost. For very expensive items, high unit cost but less in number, P system is quite useful if frequent reviews are made. Its schedule ordering approach is more appropriate. That is, an annual schedule for the procurement of materials is said to be expensive and difficult items is compiled fairly in advancement of the year commencement. This method is going to be of good usage in case of high usage value items with a fairly regular demand. It provides a tight control over the stocks, but because of the detailed scheduling, the ordering costs tend to be higher. So the scheduled ordering approach is said to be more appropriate and an annual schedule for the procurement is made and it is to be compiled in advance to the commencement of the year. In Q system, the quantity ordered each time is normally equal to Q system, whereas P system, the ordering quantity depends on the stock on hand. Q system is preferred when the supplier puts minimum quantity restriction, while P system is preferred when the supplier delivers at fixed points or at fixed periods. Q system is best suited where some continuous monitoring is possible, typically in case of the bought out items which do not constitute a major portion of the vendor's production, as the time of placing an order is more or less uncertain. In a normal case where the demand is uniform, Q system is found to be more expensive. In case of Q system, the role of safety stock is only to provide protection against variations in demand, whereas in P system it also covers the lead time demand as well as the demand fluctuations during the review period. Thus, Q system needs higher level of behavior. Queue system is more sensitive to demand fluctuations and can respond more quickly to unpredictable demand behavior. Queue system is more suitable when there are joint replenishment orders or items can be included in one order to reduce the cost, as the size of the orders is likely to be smaller than queue system. In queue system there is only one parameter, that is the reorder level, whereas in queue system there are two parameters, the reorder level and the period of review. So in queue system we have one parameter, but in P system we have two parameters, that is the reorder level and the period of review. The next inventory control technique is inventory ratios and indices. The first main ratio is inventory turnover ratio. Inventory turnover ratio are calculated to minimize the inventory on the following formula. These ratios are mainly calculated to minimize the inventory. Inventory turnover ratio is equal to cost of goods consumed or sold during the period divided by the average inventory held during the period. Average inventory will be opening inventory plus the closing inventory by 2. Cost of goods consumed will be opening inventory plus the purchases minus the closing inventory. If the cost of raw materials consumed during a particular month is 10,000 rupees and average inventory is 2,000, the inventory ratio comes to 5. These inventory ratios regarding different items of inventory may be compared with the ratios of the earlier years as well as with each other. Such comparison will result in 4 types of inventories. Slow moving inventories. These are the inventories which have a low turnover ratio and the purchase manager must have an attempt to keep these inventories at the lowest level. Next is the dormant inventories. Inventories which do not have any demand are classified as dormant inventories. A decision should be taken by the finance manager in consultation with the buyer, the storekeeper, the production controller and the cost accountant whether to retain these inventories because of the bright prospects of future demand or to cut the losses by scrapping them while they have some market value. In order to ensure that the obsolete items are immediately disposed of, there should be a well-defined system laying down the authorities entitled to dispose of such goods and the manner of disposal. Loss on account of scrapping or discarding of materials should be met from the costing profit and loss account. For the purpose of monitoring the effectiveness of inventory management, it is helpful to look into the following ratios and indices. Raw material inventory turnover ratio. Average consumption of raw material divided by average raw material inventory. Work in progress inventory turnover ratio. Cost of manufacture divided by average work in progress inventory. Finished goods inventory turnover ratio. Cost of goods sold divided by average inventory of goods at cost. The finished goods at cost. Then weeks inventory of raw material. Raw material inventory on hand divided by weekly consumption of raw materials. Weeks raw material on order. Raw material on order divided by weekly consumption of raw materials. Weekly inventory of finished goods. Finished goods inventory divided by the weekly sales of finished goods. Average age of raw materials in inventory. Average raw materials inventory cost divided by average daily purchase of raw materials. Average age of finished goods inventory. Average finished goods inventory cost divided by average cost of goods manufactured per day. Out of stock index. Number of times out of stock divided by number of times requisitioned. Spare parts index. Value of spare parts inventory divided by value of capital equipment. So these ratios may be separately calculated and they must be analyzed by the purchase manager mainly to know about the various turnover of the inventories. Next comes the input-output analysis. Input-output ratio is the ratio of new materials going into the production and raw standard materials control of the actual output. In industries where both raw material and finished products are capable of being measured in some units or quantities, the input-output ratio helps in determining whether the usage of raw materials is favorable or adverse. If standard costing is used in those industries, the input-output ratio is obtained as follows. Standard cost of quantity divided by standard cost of standard quantity. With the help of this ratio, actual working of an industry can be assessed easily. A standard ratio must be set under the circumstances prevailing in the organization. Comparing the actual ratio with the standard ratio, the real performance can be judged. If the actual ratio is higher, the performance is below the standard, whereas the actual ratio is lower than the standard, the performance is better than the standard. Take for example, the input of raw cotton is 1000 kgs. Output is said to be 900 kgs. Input-output ratio will be 1000 by 900, that is 10 by 9. That will be 1.111. Then, how to review this slow and non-moving items? The capital or the money or the investment locked up in the inventory is the money lost to the business. If more money is locked up, the lesser is the amount available for the working capital and cost of carrying the inventory also increases. Stock turnover ratio should be as high as possible. Loss due to obsolescence should be eliminated, or these items should be used in some profitable jobs. Slow moving stock should be identified and speedily disposed of. The speed of movement should be increased. The turnover of different items of stock can be analyzed to find out the slow moving stocks. The percentage of slow moving stock is shown as slow moving stocks divided by total inventory. Materials become useless or obsolete due to the changes in the product, process, design or method of production. Then the slow moving stocks have a lower turnover ratio. The capital is locked up and the cost of carrying the stock will also be incurred. Hence, the management should take effective steps to minimize the losses. Next controlling technique is the aging schedule of inventory. Classification of inventories according to the age helps in identifying which are moving slowly into production or sales. This requires identifying the date of purchase or the date of manufacture of each item of the inventory and classify them as the date shown in this following table. Age classification, date of purchase or manufacture, the amount and the percentage to be total. Age classification is 0 to 15 days, 16 to 30, 31 to 45, 45 to 60 and 61 and above. With the 15 days, a fortnight, we are going to classify the inventory. Now the date of manufacturing or purchase, December 16, December 12, November 26, November 10, October 25. So we are going to calculate. Then the amount, 8,000, 4,000, 2,000, 20, 6, etc. Now see to it, from the 0 to 15 days age, we have 8,000 amount of inventory which is manufactured in December 16, and that accounts for 20% of the inventory. With the age classification of 46 to 60 days, which is manufactured on November 10, accounts for 50% of the total inventory. The same way the other items should be understood. So, the 50% of the inventory which is lying above 45 days and below 60 days may have the risk of becoming obsolete. So, seeing about the age, that is the number of days the inventory has been stored, and with the compared with the date of purchase or date of manufacture, then we can easily find it out. See, this aging schedule is as on 31st December. So, when it is produced in November, but 50% is lying for more than 45 days but less than 60 days. So, that is said to be the risk of obsolescence. The next main thing is December 16, we have 0 to 15 days. That is the 20% of the total. Another production which is made in November 26 are 31 to 45 days, and again that counts for 5%. So, by comparing the age or the number of days the inventory is in the stores and the date of purchase, then we can easily find out which one is said to be slow moving, non-moving and fast moving. Next one comes the physical verification of materials. Proper stock records are to be kept in the bin records as well as in the store's ledger. Bins are kept inside the stores and store's ledger is kept outside the stores. Bin card shows only the quantity, but the store's ledger shows the quantity and the price. When the materials are received or issued, they are properly recorded and the new balance is struck at the end of every transaction. Principally, the bin must contain the quantity that is shown in the balance column of the bin card. But sometimes the book balance and the physical quantity will not tally. The reasons for the discrepancies may be a wrong recording in the bin card and a placement of the materials in a wrong bin, or there may be some pilferage or other natural losses that has occurred to the materials. However, such a situation will emphasize the need for the physical verification of the materials in the storeroom. The physical verification can be made periodically or it may be made continuously. When it is made periodically, it is called as periodic inventory verification, and when it is made continuously, it is called as perpetual inventory verification. Under the periodic inventory verification method, all the items of storeroom are verified through counting, weighing, measuring, etc. at the end of every specific period. Usually, it may be the last day of the accounting year. They can also be verified at the end of every quarter, or it may be verified half yearly or monthly or fortnightly. So, the period of verification may depend upon the requirements of the organization. They can also be verified fortnight or week, etc. In the light of this verification, the materials are to be verified only once on the last day of the accounting year. It is also required by the accounting system to value the stock in hand on the last day of the year for the purpose of preparing the annual accounts. The issues are not made during the stock verification. Usually, additional staff members will be employed in the verification of stock. This method gives a correct picture on the last day of the accounting year. Though we say that the materials can be physically verified periodically, either half yearly or quarterly or weekly or fortnightly, but a normal customary method is to verify it at the end of the accounting year. Then perpetual inventory system. Perpetual inventory system is a system of records maintained by the controlling department which reflects the physical movement of stocks and their own correct balance. This is the method of ascertaining balance after every receipt and issue of materials through the stock records to facilitate the regular checking and to avoid the closing down of the stores for stock taking. In order to ensure the accuracy of the perpetual inventory record, it is desirable to check the physical stocks by the system of continuous stock taking. Any discrepancy noted between the physical stocks and the stock records can be immediately investigated and rectified. So we say, for example, if you have 100 items in a store, so 10 items will go in for the checking, and after checking the 100th item, they will come again for the first item. So that will be a continuous or a perpetual inventory control system. The success of this perpetual inventory system will depend upon the maintenance and the updating of the records with the quantities and the amount, and again the accuracy of the stores ledgers and the bin cards, reconciling the balances shown by the bin cards and the stores ledgers, checking the physical balance of number of items every day systematically and by rotation. This rotation is very important. By rotation, we have to say about the members of the staff, and again the number of the units to be checked. Explaining promptly the causes for the discrepancy between the physical balance and the book figures. That may be due to some evaporation or shrinkage or mishandling, etc. So you have to say about the discrepancies. Then reconcile those discrepancies. So this perpetual inventory system deals with the various advantages, and it resolves for the various advantages, and that advantages are as follows. The discrepancies that are noted after the physical verification can be easily located, and remedial actions can be taken, and this can be avoided in the future period. The closure of the stores is not necessary for annual stock taking. Again, the movement of the store items can be observed very closely by the store's auditor, so that the chances of obsolescence or unnecessary buying can be reduced. As the inventory is continuously checked, the non-moving items, the obsolete items can be easily identified, and once again the unnecessary buying can also be avoided. Since the stock figures are available quickly, it facilitates the compilation of the profit and loss account and the balance sheet at the interim periods also. Overstocking and understocking can be avoided because actual stock can be compared with the authorized maximum and minimum limits. It obviates the need for physical verification of all the stores at the end of the year. The system generally has a very good effect on the store staff because it goes for the element of the surprise visit. So the store staff will be more vigilant enough, and he will not be knowing which item is to be checked now and who is going to come and check and what will be the date of visit, etc. Then the work is spread throughout the year, so the full time of the specialized staff can be used in this purpose. So these are all the major advantages of a perpetual inventory system. So as a continuous control is maintained, or continuous physical verification is maintained, we are going to identify the obsolete items, non-moving items, and the unnecessary purchase can be avoided. And once again, the checking can be done continuously. We are going to have the discrepancies noted at the earliest, and once again the reasons for the discrepancies can be found and remedial actions can be taken, and this can be avoided in the future also. Again, the closure of the stores or the factory is not needed as the continuous checking is made. So the auditor in charge, or the person who is checking, will be having a surprise visit and he is having the program as a confidential one, so that the storekeeper will not be vigilant enough to maintain the stocks. Say the person who is going to check the materials or the physical verification will not reveal who will come for the checking and which date the checking will be done and what are the materials to be checked. So nothing will be revealed to the storekeeper. So storekeeper must be alert at all points of time, and he has to maintain the inventories in a regular manner. And once again, the bin cards and the stores ledger should also be updated and no discrepancies should be there. As the stock taking is completely checked continuously, the preparation of the profit and loss account and the balance sheet at the end of the accounting year is considered to be very easy, and the control over the investment in the stocks can also be made, and the time of the specialized stock will be used in a very effective manner, and this will be a moral check in the minds of the store staff, and he is going to maintain all the levels of inventories in a perfect manner. So these are all some of the inventory control techniques that can be used by the organization. The economic ordering quantity, the various levels of the inventory to be maintained, inventory turnover ratios, aging schedule, input-output ratios, perpetual and periodical stock taking systems will be some of the inventory control techniques, and the manager, stores manager or a purchase manager will have a control over the investment in the stock by following all these techniques. Thank you.